It is evident that rapid computation is essential for building a taxi without a driver, or decoding a pin by factorizing a large number. But it seems that many claims about the immediate benefits of quantum computing are both problematic and groundless. Nowadays, it can be often heard those claims in media that quantum computing can help new drug discovery. Quantum computing can be used to realize nuclear fusion. Quantum computer can help weather and climate research. And quantum computing can help physicists to understand the universe or the parallel universes. For people who are unfamiliar with those research areas, such claims sound very exciting indeed. Nevertheless, if you could talk with people who had worked as researchers, like me, you might think those claims twice. Welcome to Yung Tuition. I am Yung. Today, I'm going to make some remarks on whether computation can eventually replace research in science. Let's go and have fun. Several decades ago, one of my colleagues was using a primitive computer to calculate energy levels of metal ions in diamond and other crystals. I remember I was skeptical about the importance of his research. At least, I didn't think he was doing basic research in condensed matter physics. Several years later, after I read many original papers on magnetic resonance by Bloch, Bloembergen, and P.W. Anderson, and so on, I had convinced myself that I am right. In fact, none of these great physicists used a computer or abacus. In my opinion, when every formula is given for each step of computation, it is just a matter of coding to optimize parameters used in a model, similar to doing the 4 rules in primary school. In human history, many methods and tools were invented to speed up the computation of numbers, such as Pascal's triangles and the abacus I used before. Of course, with the advent of electronic computers, more complicated calculation can be done faster, say the energy level of carbon dioxide and its infrared absorption spectrum as shown here. Unlike building an AI-driven car, the computation speed for doing research seems unimportant when general theory remains to be explored. For example, in 1986, a new type of high-temperature superconductors was discovered by Benolds and Mueller. To many people's surprise, their superconductor was found from ceramics or electrical insulators rather than a good conductor. Such a paradigm shift in discovering superconductors can hardly be obtained by a logical analysis and computation. Bearing in mind that any computers, electronic or quantum, must strictly be based on human logic. Hence, illogical thinking is forbidden. However, many conceptual breakthroughs made by great individuals such as Galileo, Faraday, Bohr, and Dirac are not based on seemingly well-established theories or consensus, let alone computer simulations. Hence, to claim quantum computing can speed up humans' understanding of the nature is nonsense. In discovering new drugs, for example, doing real experiment remains the most important approach, although it can be assisted to some degree by moderately using computer simulation or 3D modeling. Such a biomolecular modeling looks real, but it is not real at all. I remember in the 1990s, from time to time, one could hear from ABC News that researchers developed new drugs by finding a molecule with right size and right shape so that it can be inserted into a gap or the hole in a protein. Of course, now we know they're all fake news. How about nuclear fusion? The race to use nuclear fusion as a clean energy source started over 60 years ago. Today, however, nobody can tell us when a controllable nuclear fusion reactor could be available. In short, the challenge in the field is beyond computational. It is absurd to believe controllable fusion can be realized by using quantum computer. In relation to weather forecasting, it had been proven by Lorentz in the 1960s that long-term weather forecasting is impossible due to the chaotic nature of the atmosphere, irrespective of how fast a computer could be. So that is another scam. As I have recently shown that the theory for computing CO2 absorption in the atmosphere is fundamentally wrong, as the surface is always in contact with air at a strong atmospheric pressure. Therefore, it cannot emit any infrared ray. So I don't think a quantum computer can be of any help in that regard. In fact, it could be argued that further exploring fundamental issues in physics, computation is either secondary or even completely unnecessary if you knew what had happened in the history of physics. For example, when Paul Dirac tried to unify the two seemingly different quantum mechanics theories formulated by Heisenberg and Schrödinger respectively, he didn't use any computation at all. Instead, it occurred to him that the breakthrough might lie in the general mathematical form of Poisson brackets in the Hamiltonian mechanics, which of course has nothing to do with numerical computation. In 1954, Young and Mills proposed their Young-Mills field as kind of the standard for formulating quantum fields called gauge theory in order to eliminate the unwanted terms in the general Lagrangian. But the theory completely failed in explaining the mass of boson. How did the breakthrough was made 10 years later? I will discuss this in detail next time. But I can tell you now, it also has nothing to do with computation. In short, computation or computer simulation can never replace research based on experimental measurements and creative thinking. I hope you would find this talk informative and interesting. If so, please like, subscribe, and make some comments. See you next time. The blue curve is theoretically calculated, which is to be explained soon. As you can see, the coordinates of the three planets, namely Mars, Earth, and Venus, can be quantitatively predicted. Is that beautiful? I remember my teacher said Newton was merely puzzled by the first push because he believed that his mechanics to fix the fundamental problems of the standard model, isn't it? Let's remember C.G. Ozawa, my favorite conductor, who created joy. Arrhenius claims CO2 is the chief absorbent on his paper, page 260, without any direct experimental evidence, such as this one demonstrated with this Newton's cradle. As you can see, something must have been transferred among the metal balls. But what is this something?